Dear friends, and a warm welcome to this session on India's largest online live learning platform by Gradeup Super. You are watching me live on Gradeup GATE YouTube channel, my dear friends. I welcome you all on this session. The subject that we are going to discuss is strength of material. This is the third class, and the topic is shear force and bending moment, my dear friends. So I will tell you the simplest way to solve the problem of shear force and bending moment, which will be asked in the competitive exam. Generally, my dear friends, we are very much confused about what is the load which is acting, whether we have to take the positive values or negative values, how much is the magnitude of the shear force, how much is the magnitude of the bending moment, all those things, my dear friend. Is it clear? So, my dear friends, am I audible clearly to all of you? Yeah, good evening. How are you? Imtiaz, Vikas Yadav, Karnam, Veer, Nagarajan, Soumitra. Very good evening, all of you. So, any doubts in the last two topics, my dear friends? See here, on oblique plane, the normal stress value is equal to sigma x cos square theta plus sigma y sin square theta plus tau xy sin 2 theta. If I want to write down in terms of 2 theta, this will also become sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2 theta plus tau xy sin 2 theta, my dear friends. So writing sigma cos square theta and sin square theta in terms of cos 2 theta, this will be the answer. Naveen, how you are getting the other PDFs? Can you tell me? Are you on any Telegram channel? If you are there, I will just share there also. Aman, yeah, Hitesh, generally where you get the PDFs? Can you tell me? Are you getting it on the app or Telegram channel? Okay, you are getting it on Telegram channel. So I will just share it now itself. If you are there on the Telegram channel, just a minute. Imtiaz, but if you use the formula in, I am getting wrong answer. I will send it on Telegram channel. I thought through this you are getting it. So I already forwarded, my dear friend. Is it clear? Right. So let me start here. Before starting, I would like to introduce myself. My name is Rushi Joshi. These many years of experience in training aspirants preparing for competitive exam. These many students I have mentored. Uh, this is my gate score. Engineering, mechanics, strength of material, and machine design are the subject of my expertise, my dear friends. So I already posted, my dear friends. You just see there on Telegram channel, right? So can you tell me what do you mean by shear force and what do you mean by bending moment, my dear friends? Yes, everybody, I have forwarded the PDFs. Yes, Naveen, Aman, I have forwarded the PDF. You just check it out. Can you tell me what you mean by shear force? Yes, my dear friends. Just now I have done it, Hitesh. Just now I have forwarded it on the Telegram channel. Right? So what is shear force? Can you tell me, my dear friends? Yes, this session is for civil also. I will do that. Hemant, Nagarajan, I will do that. Shear force is the unbalanced force at a section of a beam. At a section of a beam. So whatever amount of leftover force is there, that is called as shear force, my dear friend. For example, if I consider a cantilever beam subjected to load, transverse load P on it, So my dear friends, you see that this force at B point will be having some shear force. So how to get the shear force? So here first I will take a section B1. This section is B1. So the shear force at B1 is equal to how much? Can you tell me? Yes, it is a parallel force, my dear friends. It is a parallel force. Yes, you can see the channel name. Yes, my dear friends. So shear force at B1 is equal to how much? So my dear friends, on the right side of this B1, you see there is nothing. Since there is no force, no unbalance, hence the answer at this point is 0. Now we'll take one more section. B2, taking P on the right side. So what is the shear force at B2? Shear force at B2 is equal to how much? So this is B2. On the right side you have got a force P. So my dear friends, you require the same amount of force P in the opposite direction to balance this, and this is called as shear force. So the amount of force required to balance this on this B2 section is called as shear force. So shear force is same magnitude P but in the upward direction, hence positive. Is it clear to all of you? So there are two values of the shear force at B point and the magnitude varies from 0 value to P value. Very good, my dear friend. This is clear, right? So my dear friends, you see that the amount of force which is acting is W on the cantilever beam, but when I take a section somewhere that is in the middle, that is C1 or CC, you see that on this section the amount of load is acting down, the amount of reaction, these are called as the reactions or internal forces, right, to balance this W. So the amount of force required to balance this W is acting upward, hence it is regarded as plus W, my dear friend. Is it clear now? This is called as shear force. Is it clear? Aman, already it is been posted by Naveen about the channel. Yes, you can see it is Gradeup ESE GATE mechanical preparation. So can you tell me what do you mean by bending moment? Yes, my dear friends, what do you mean by bending moment? What do you mean by bending moment? It is the unbalanced movement, unbalanced movement at the section of the beam. Movement at section of a beam. Section of beam is called as bending moment. Is it clear now? So force into perpendicular distance is movement, but section of a beam, if you cut the section, the unbalanced movement is called as bending moment, my dear friend. So you see that if you take this type of movement acting here, the top fibers are subjected to compression, whereas the bottom fibers are subjected to tension, my dear friend. This is compression and this is subjected to tension. So let me tell you that if I draw the shear force bending moment for this, can you tell me what is the bending moment at B? Bending moment at B is equal to P is the load, perpendicular distance is 0. So the answer for the bending moment is 0. Now, can you tell me what is the bending moment at a distance x from B? So bending moment at x is equal to how much? Yes, bending moment is the moment which is caused because of the bending of the beam. So my dear friend, bending moment at B is equal to 0, but what is the value of the bending moment at x? Yes, my dear friends, what is the value of the bending moment at x? Very good. It is P into x and it is a hogging moment. Hence it is regarded as negative. Right? This is what we have studied. So very clearly I will just explain you with an example just now. Is it clear? So I will just explain you with an example. So the shear force is the unbalanced force at a particular section of a beam, and the bending moment is unbalanced moment at a section of a beam, my dear friends. So my dear friends, just a minute. Now suppose if I take a cantilever beam subjected to end load. So this point is A and this point is B and there is a load P acting here. Now can you tell me, my dear friends, what is the value of the shear force at B? Shear force at B is equal to, one value is 0 if I take a section here, and shear force at B is equal to P value of magnitude how much if I take 2 section. This is 1 section, this is 2 section. So at section 2 and this is at section 1. So what is the magnitude? Magnitude is P, which is acting downward, right? So whatever is given on the left side of the section is called as the shear force. Hence it will be minus P here. So my dear friends, you see that the shear force, if I consider a section, this is section, please try to understand this. So when the load is acting down, the shear force is regarded as positive shear force. And when the shear force is the load is acting up, this is load. So the shear force is equal to negative shear force. Means whatever is given opposite to that is the shear force. So this is right side of the section, my dear friend. So whenever you solve the section on the right side of a particular section, you take conventions opposite to engineering mechanics conventions. What was your engineering mechanics conventions? Yes, it is right. Upward is negative, right upward is negative. Is it clear now? So my dear friends, we have to consider the conventions which are opposite to engineering mechanics conventions. What are engineering mechanics conventions? Engineering mechanics conventions are upward is positive, right side is positive, left side is negative, downward is negative, my dear friend. This is our engineering mechanics. Is it clear now? This is our engineering mechanics. Nagarajan, Sushmita Das, I will send you. I will send you. Don't worry. Wait for some time. I will send you. Right? So on left side, you see, my dear friend, if the force is acting down, the shear force is negative. The shear force is negative, and when the force is acting up, the shear force is positive. Means you are taking as it is. So same as your engineering mechanics conventions. So my dear friend, please keep in mind that whenever you solve the section on right side, whenever you solve the section on right side, right, whenever you solve the section on the right side, whatever is given opposite to that is shear force, and when you are solving the section on the left side, whatever is given is the shear force. Is it clear now? Whatever is given is the shear force. So for example, for example, for example, if I take a section on this point and solve right side, right, and the loading is like this is 10 Newton, this is 5 Newton. So what is the shear force at X? Shear force at X is equal to whatever is given opposite to that I should take it. So 10 and 5 are given which are acting down, opposite to that is upward. So the answer for the shear force is plus 15. Is it clear to all of you? But when I take on the left side, when I take on left side, one is 15 Newton and one is 20 Newton, right? 20 Newton. This is just an example, my dear friend. One is 20 Newton, one is 10 Newton. So the shear force at YY is equal to whatever is given here, 20 acting down minus 15 acting down minus. So the answer is minus 35 Newton is the answer. Is it clear to all of you? Yes, my dear friend, is this clear to all of you? Right? Is this clear? So wherever you take a section, you either solve right side or you solve left side. Is it clear? So if you solve right side, whatever is given opposite to that is shear force, and on the left side, whatever is given is the shear force. Right? Clear? Now the second note is the shear force takes a vertical jump, vertical jump with point load. So my dear friends, whenever you see there is a point load acting, there are two values of the shear force, and the difference between that two value is the amount of load. So for example, my dear friends, you can see here, this is the beam, and if I draw the shear force diagram here, you see that this force at B point, the answer varies from 0 value to minus P, and constant up to this, and again from minus P to 0. So my dear friend, at A and B there is a vertical jump and the difference in that value is equal to P itself. So right, see here which side is best means depending upon the question. If right side there are less forces, you solve that. If left side there are less forces, you solve this. Is it clear now? So it's better you solve left side if both are same, because whatever is given is the shear force. Is it clear now? Right? Is it clear now? See, Nagarajan, it depends upon the question. We need to save our time in the examination. You can solve left side, you can solve right side. So in which section the forces are less, that forces you consider, because your calculation will be reduced and time is saved. Is it clear now? Clear? So now you see that this is what the shear force diagram for this problem that you will be getting it. So at B point and A point there are vertical jumps because of P Newton acting here, and you see that there is RA value which is also equal to P reaction. So my dear friend, because of this there is a vertical jump because of point load, that is RA, and here there is a vertical jump because of point load P. Is it clear now? So your shear force diagram take a vertical jump with the external moment. Now third case, my dear friends, if I talk about the bending moment, bending moment takes a vertical jump, vertical jump with external moment, with external movement. So whenever you see that there is an external movement acting on the beam, compulsory there are two values of the bending moment. For example, if I see this, the bending moment at B is equal to P is the load, perpendicular distance is 0. So the answer at this point is 0. But if I take a distance x, my dear friends, can you tell me what is the value of the bending moment at x? Bending moment at x is equal to P is the load, perpendicular distance is this, and this is hogging. So there are two types of movement that we need to consider. One is a hogging movement. What do you mean by hogging movement, my dear friend? So whatever be the section, if your beam is bending down, whether the section is on right or left, anywhere, if your beam because of the load is bending down, we call it as hogging moment, and the bending moment for this will be negative, my dear friend. Is it clear to all of you? And if you see that the beam is bending up, if the beam is bending up, we call it as sagging moment. So in what case it will move up? When the load is from bottom to top, the beam will be moving up because of the load, and the bending moment is regarded as positive bending moment. So now because of this load, the beam at B will be moving down, hence we call it as hogging, hence you get minus px. So what is the bending moment at A? Bending moment at A is equal to P is the load, perpendicular distance is L, and this is hogging. Hence the same straight line comes here. So the answer for the bending moment at this point is this. Yes, hogging moment are downward movement and sagging moment are upward. So anyone, depending upon the load, we have to take positive or negative. Don't go with your engineering mechanics. Anti-clockwise positive, clockwise negative. Don't take that. If the beam is bending down, you take bending moment as negative. If the beam is bending up, you take the bending moment as positive. That's it. So now you see that there is a vertical jump at A, and at A, bending moment at A is equal to 0 to minus PL. Because of what? Because of MA. So there is a movement reaction at this point. There is a movement reaction at this point, and because of this EMA, there will be a vertical jump. Is it clear now? Because of this, there is a vertical jump. Is it clear now? Right? So my dear friends, now you see, suppose for example, I have taken a beam, and this is the section. I have got 5 Newton load at 2 meter, 10 Newton load at another 2 meter, 15 Newton load at another 2 meter. So I want what is the value of the bending moment at x. Bending moment at x is equal to, please focus my dear friend. So how many loads are there? 5, 10, 15 are 3 loads. What are the perpendicular distance of 5? Perpendicular distance of 5 from x is 2. Perpendicular distance of this is 4. Perpendicular distance of this is 6. So 5 into 2, 10 into 4, 15 into 6, and all three are giving hogging moment, my dear friend. So if I take the second one as positive, 10 Newton. So now you see that 5 into 2 is hogging, 10 into 4 is sagging, so positive, 15 into 6 is hogging, hence negative. So what will be the answer? 15 into 6 is how much? 90, and 10, 100 minus 40. So the bending moment at x is equal to minus 60 Newton meter. Is it clear now? This is the answer. See here, I have changed the direction of 10. Yeah, new one is minus 60. So every load you take the perpendicular distances separately, and accordingly you proceed, my dear friend. Is it clear to all of you? Is this clear? Right. Now one more thing. Whenever you see that there is a point load acting, for point load, your shear force diagram is constant straight line, and bending moment diagram is linear. For UDL, your SFD is linear, your BDMD is parabolic. For UVL, this is parabolic and this is cubic. Is this clear? Very good, my dear friends. Yes. So my dear friends, shear force and bending moment, if you see that for a cantilever beam, if the load P is acting up, you see that this is the section, and right side of the section, if the load is downward, we see that the shear force is positive. On the right side of a section, the shear force is positive for downward load, and on the left side for the upward load. And bending moment for any section, if it is sagging, the bending moment is positive, and if it is hogging, the bending moment is negative. Is this clear? In case of concentrated movement, my dear friend, in case of concentrated movement, suppose there is a concentrated movement acting here like this, so your bending moment will be just a vertical jump. So bending moment at B is equal to, bending moment at B is equal to, one value is 0, another value is hogging 1, which is equal to minus m. So from 0 it will go to minus m, constant up to this, and you see that the bending moment goes up from minus m to 0. Is it clear now? So there is a vertical jump here because of m, and there is a vertical jump here because of ma. Is this clear to all of you? Yes, Messi. Is this clear, my dear friends? SFD is 0. This is SFD and this is BMD. So first derivative of the bending moment with respect to x is called as shear force. So if this value is 0, means bending moment is constant. This is called as pure bending condition. Is it clear now? There is no shear force. So what is that we need to do it, my dear friends? First we should draw the free body diagram. So when you draw the free body diagram, you see there are load P1, P2, this is P1, this is P2, and it is hinged at this point, and it is having a roller support. So this is VA, this is HA, and this is RB. So likewise we need to draw the free body diagram, and once we draw the free body diagram, my dear friends, once we draw the free body diagram, then we find out the magnitude of the reactions. Next, find the magnitude of the supports and the reactions. One is called as statically determined truss, where summation of vertical is equal to 0, summation of horizontal is equal to 0, and summation of the movement about some point is equal to 0 is satisfying. We call this truss as statically determinate truss. When there are 4 reactions and 3 equations, we cannot find out the unknowns, and that type of truss or a beam is called as statically indeterminate. And my dear friends, in our syllabus we have got only statically determinate trusses where there are 3 unknowns and 3 equations to solve, my dear friend. Yes, it is pure bending. If there is no shear, it is called as pure bending. Only normal stress will be there. Is it clear now? So if the shear force is equal to 0, shear stress is also equal to 0, then we have only bending stress sigma b, and that to maximum. Is it clear now, Nagarajan? Yes. And the third step, my dear friends, is we need to find out the shear force by cutting a section. So what we'll be doing, we'll be taking a section at the point where the question is asked to you. So we'll be taking a section XX at a distance S. So whatever is the load opposite to that is called as the shear force. So this is called as shear force, and this is called as a bending moment at the section of the beam. Is it clear now? So this is how at every section we should find out the value of the shear force and the bending moment, my dear friends. Now the sign conventions, you can see that for the shear force is positive. The shear force is positive if you take right side of the section. This is section. If you take right side of the section downward, right side of the section downward and left side of the section upward, the shear force is positive. The shear force is positive. Shear force is positive. And if you get a sagging moment, the bending moment is positive. Now negative. Right side upward is negative. So from a section, if you take right side upward, you get the shear force as negative, and left side downward is negative shear force. And for an hogging moment, the bending moment is equal to negative. Is it clear? So when the load is a point load, acting here, your SFD is constant, and BMD is linear, For UDL, your SFD is linear and BMD is parabolic, and for linear, which is UVL, your SFD is parabolic and this is cubic. So my dear friends, can you tell me how to find out the shear force and bending moment for this? So this is A point, this is B point. So your first step is find reaction, RA and RB. So your RA is P by 2 and your RB is P by 2. So my dear friend, when I draw the shear force diagram, the shear force at A is equal to one value is 0 and another value is P by 2, which is acting up, so it is plus. So my dear friend, it will vary from 0 to plus P by 2, constant up to C point. And here you see that the shear force at B is equal to 0. The shear force at B is equal to minus P by 2. So it will go to minus P by 2. Constant up to this. And you see that at this point, it will vary from minus P by 2 to plus P by 2. And the difference in these two is equal to the load itself. So this is negative shear force, this is positive shear force, and this is the point where the shear force is equal to 0, means bending moment is maximum. Is this clear? Bending moment is maximum. Difference between parabolic and cubic. So y is equal to x square is parabola, y is equal to x cube is cubic. Right? Now I know that the first derivative of the bending moment with respect to x is called as shear force. So from this, if I take bending moment, it is equal to SF dx. So integrating on both sides, the bending moment is equal to area of the shear force diagram, area of SFD. So my dear friend, what is the area of SFD? Area of SFD is A1, which is equal to P by 2 into L by 2. So the answer for this is PL by 4, and this value is called as maximum bending moment at C. So my dear friend, you see that the shear force at this point is 0. Sorry, bending moment at this point is 0. at A is 0. Bending moment at B is also equal to 0. But the bending moment at C is equal to PL by 4, and that too linear. You can take area A1 or you can take area A2. So this is also equal to area A2. So at any point, if you want the bending moment of a particular point, either you take left side area of the shear force diagram or the right side area of the shear force diagram. So you will get the answer for the bending moment at that point. Is it clear to all of you? So directly you can get the answer for this. Next, for UDL. Now tell me, what is the reaction at A and B? Yes, my dear friends. RA is equal to and RB is equal to how much? RA and RB is equal to how much is RA and how much is RB? Yes, my dear friends. Are you getting it? How much is RA and how much is RB? Very good. It is equal to WL by 2 and this is also equal to WL by 2. So if I draw the shear force diagram, the SFD at A is equal to 0. Another value of SFD at A is equal to plus WL by 2. So it will vary from 0 to WL by 2. And here it is, shear force at B is equal to 0 and shear force at B is equal to minus WL by 2. And you see that the shear force for UDL is linear. So this is the point C where the shear force is equal to 0, implies that the bending moment is maximum. And if I take area A1 or A2, so area A1, which is equal to area A2, is equal to the bending moment at C, which is equal to half WL by 2 into L by 2, hence becomes WL square by 8 is the value of the maximum bending moment. Bending moment maximum is equal to WL square by 8 is very important, my dear friend. So the bending moment at B is equal to 0. The bending moment at A is also equal to 0. But the bending moment at center C is equal to WL square upon 8. And this is parabola. Like this. Is it clear now? Is this clear? Everybody? Yes, my dear friends, are you understanding, enjoying the session? So very fastly click the like button, press the bell icon, share and subscribe with your friends, my dear friend. We are not interested in increasing or decreasing. So from 0, it will go up to this point, and if I take from this side, it is increasing from 0 to WL by 2. So this is increasing from here and decreasing from this here. Like this you can take it if you solve the problem from one side. See here, my dear friends, dm by dx is equal to shear force. So dm is equal to SF dx. So the bending moment is equal to, if I integrate it, bending moment is equal to area of shear force diagram. Area of shear force diagram is called as bending moment, my dear friend. Right. right? Left side and right side it will be same. Imtiaz. Left side and right side it will be same. So my dear friend, let's proceed for some questions, my dear friends, on the screen. So only that five points you remember. Shear force diagram takes a vertical jump with point load. Bending moment diagram takes a vertical jump with external movement. Your shear force diagram on the right side of the section is opposite to whatever is given. On left side, whatever is given is the shear force. If you have got a hogging moment, you will get the negative bending moment. If you got a sagging moment, you will be getting a positive bending moment. It will be same. Yes, Ajay, what is your doubt? For UVL, how to calculate the shear force? I will just tell you for UVL how to calculate the shear force. Just a minute. So my dear friends, if you see that there is a load acting here, sorry, there is a UVL acting here with zero magnitude, with zero on left side and maximum W per unit length on the right side. So this is 0, this is W per unit length, that is Newton per meter, length is L, this point is A, this point is B. So what is the value of RA and RB? Your RA is equal to total load, that is half W into L divided by the total length and the distance of the load from the other end. So what is the load? Load is half WL, area of the triangle, and it is acting at a distance of L by 3 from the base and 2L by 3 from the apex. So this distance is multiplied with L by 3. So this will becoming the answer as WL by 6. So your RA is equal to WL by 6 and your RB is equal to WL by 3. Now you see that the shear force at A is equal to 0 and another value of the shear force at A is equal to WL by 6. So it is varying from 0 to WL by 6, which is positive. And here you see that the shear force at A is equal to 0 and another value is the shear force at A is equal to minus WL by 3, which is acting down and slightly more than greater than WL by 6. Is it clear now? So you will be getting a parabolic distribution here. You will be getting a parabolic distribution at this point, my dear friend. So this is the point C where the shear force is equal to 0 and the bending moment is maximum. And the bending moment is maximum. Is it clear to all of you? Is it clear now? So what are the 5 points, my dear friends? Let's see here. So the 5 points are, first one is shear force diagram takes a vertical jump, with point load. Second one, bending moment diagram takes a vertical jump. So there are two values at that point. takes a vertical jump with external movement. Means there are two values. Now your third one will be, if you solve the right side of the section, so whatever is given, opposite to that is shear force. So given is this one, this is given, opposite to that is the shear force. So shear force is positive, downward shear force is positive, and the shear force is negative, and the shear force is negative. Means whatever is given, opposite to engineering mechanics convention, opposite to given is shear force. So here you see downward and upward, so the shear force is negative here and the shear force is positive here. So whatever given is shear force. Third point. Fourth point for hogging moment like this, the bending moment is negative. For sagging moment, means like this, the bending moment is positive. See, Om Hari Rajput, we are not interested in the type of curve, whether you are getting positive or negative, upward or downward. Is it clear now? So we are not interested in the direction of that. Ajay, the application of the flexural formula is M upon I is equal to sigma by Y is equal to E by R is used in bending, my dear friends. So it will give you the bending stress. So to understand the beam's critical condition, we use the pure bending formula called as a flexural formula, my dear friends. Is it clear? And the last fifth point is for point load, your SFD is constant and BMD is linear. For UDL, your SFD is linear and BMD is parabola. And for UVL, this is parabola and this is cubic. Yes, because what is your doubt? So here you see that the bending moment diagram, if I take it, the bending moment at A is equal to 0, the bending moment at B is equal to 0. So at this section we find the shear force at X. So this distance is X. So shear force at X is equal to 0. Find X. So at what distance it is 0? So once you do that, then write down the bending moment at X, which is equal to WL by 6. Perpendicular distance is X, right? Which is giving sagging and half WX upon L into X multiplied with X by 3 from the base to X by 3 from the apex. So it is X by 3, right? And this is hogging. substitute x value, you get maximum bending moment. So here x is equal to L by root 3, and when I substitute x is equal to L by root 3, the maximum bending moment is equal to WL upon. So the value of the maximum bending moment is equal to WL square divided by 9 root 3. So here it is 0. It will go up. It will go up. This is L by root 3, and this is equal to WL square divided by 9 root 3. How to calculate x? So write down the shear force at x. Shear force at x is equal to WL by 6. If I take a section here, this is WL by 6 upward. What is upward? Whatever is given is this, minus half WX by L into x is this triangle. So the area of the triangle is half WX by L into x, right? And this value is equal to 0. So from this, x is equal to L by root 3. Shear force at x is 0, and at L by root 3 the bending moment is maximum. So substitute this L by root 3 in this equation, you will be getting the maximum bending moment. Is this clear now? Yes, what is your doubt, baby? Because we are not interested in parabola and this one. If it is positive bending moment, then you will be getting so if the parabola is like this, if the bending moment is positive, you get the parabola like this, and in the cantilever beam UDL, you get the bending moment in this way, right? Minus kx square, this is y is equal to kx square. X is the distance where the shear force is becoming 0. X is the distance where the shear force is becoming 0, baby. Is it clear now? X is the distance where the shear force is becoming 0. So if it is clear, my dear friends, if it is clear, let's proceed for some problems, my dear friends. So the first question is, a simply supported beam is loaded as shown in the figure. The maximum shear force will be, what is the value of the maximum shear force? This is A point, this B point, this is C, D and E. The value of the maximum shear force is, So maximum shear force is equal to maximum reaction in the beam. So this is RA. RA is equal to total load is 4W divided by 2, which is equal to 2W, and RB is equal to 4W divided by 2, which is equal to 2W. So the answer is equal to 2W, my dear friend. Since loading is symmetrical. So whatever is the maximum reaction in the beam, that is called as the maximum shear force, Naveen. It is not 4W, it is 2W. So C is the right answer to this question. Let's proceed for the next question, my dear friends. A steel beam loaded as shown in the figure. The maximum bending moment is, so bending moment maximum is equal to, what is the value of the maximum bending moment, my dear friends? So it is WL square upon 8. So W is given as 120 into 15 divided by 15 square divided by 8. So 4 2 8, 4 3 is 12. This is 15. So the answer comes out to be 3375 kilonewton meter. Is the right answer to this question. So let's proceed for the next question, my dear friend, on the screen. Figure shown represent the bending moment diagram for a simply supported beam. The beam is subjected to which one of the following? The beam is subjected to which one of the following? Yes, Abhinandan Kumar, 6750 is wrong. 6750 is wrong. It is WL square by 8. See here, this is RA and this is RB, right? So RA is equal to, if this is W, so this is WL by 2 and this is also equal to WL by 2. So when I draw the shear force diagram, it will vary from 0 to WL by 2 and it will vary from 0 to minus WL by 2 and you will be getting a linear curve. So at this point, you see that the shear force is equal to 0, means bending moment is maximum. So either you take area A1 or area A2. So the maximum bending moment is equal to area of the shear force diagram, which is equal to A1, which is also equal to A2. So this is equal to half WL by 2 and this distance is L by 2. So the answer will become WL square divided by 8, not 4. Is this clear now? Yes. Abhinandan Kumar, Sushmita Das, is it clear now? So be careful. This is very important. Compulsory will be asked because we make mistake here. Because we make mistake here, this will be asked in the competitive exam compulsory. Right. Let's see this. Figure shown above represent a bending moment diagram of a simply supported beam. The beam is subjected to which one of the following? The concentrated load at the mid length, the uniform distributed load over the entire length, a couple at the mid length, or a couple at L/4 from the each end. So I told you that no, for a simply supported UDL, for a simply supported UDL, for a simply supported UDL, the shear force diagram is linear and bending moment diagram is parabola. So B is wrong. Concentrated load, shear force take a vertical jump. SFD takes a jump. So it is at the center. This distance is plus m. This distance is minus m. So the value varies from minus m to plus m. So obviously there will be a couple. There will be a couple added mid length. There will be a couple added mid length. So B is the right answer to this question. Sorry, C is the right answer to this question. Since bending moment diagram takes a vertical jump, with external movement or couple. Means there are two values of the bending moment. So C is the right answer to this question. Very good. So let's proceed for the next one, my dear friends. A beam is made up of two identical bars AB and BC by hinging them together at B. End A is built in and the end C is simply supported with the load P acting as shown in the figure. The bending moment at A is, so what is the value of the bending moment at A? Bending moment at A is equal to, what is the value of the bending moment at A? Yes, my dear friends. No, couple at L/4 is now. So when you take a couple at L/4, there should be a vertical jump at L/4, but in the problem it is not there. Akhilesh, if there is a couple at L/4, there should be a vertical jump at L/4, but we don't have any vertical jump at L/4. So no vertical jump at L/4. No vertical jump. Vertical jump at L/4. So that is wrong. Yes, my dear friends. So this beam can be taken as A to B. This is A, this is B, and second one is taken as BC. So since there are two different beams, you see that there is a load P acting at the center. So obviously there will be RB here and there will be RC here, and the value is equal to P/2 and P/2. So my dear friends, since it is an internal hinge, so you get RB here also, and this RB is equal to P/2. So these two balance each other. So the bending moment at A is equal to P/2 is the load, perpendicular distance is L, So the answer is PL by 2 is the right answer to this question. No. Shaktiman, can I know your name? C is wrong. So since it is given as two identical AB and BC, so we need to separate AB and BC. Since at B we have hinge, so AB and BC to be separated. To be separated. Is it clear now? So let's see the next question, my dear friends, if you don't have any doubts. So my dear friends, I am seeing that you are dull today, everybody. I am not seeing any Josh in you. Yesterday and before that class, it was very good Josh was there. Next, the shear force diagram of a loaded beam. The shear force diagram of a loaded beam is shown in the figure. The maximum bending moment of the beam is, so the value of the maximum bending moment is equal to, so what is the value of the maximum bending moment? No, Imtiaz, it is not a conjugate beam. It is the beam with an internal hinge. It is a beam with an internal hinge. Yeah, decent boy, you sleep. Right. So my dear friends, you take either area A1 or A2 to get the answer for this. So shear force at C is equal to 0. Bending moment at C is maximum. Right. So area A1 is equal to, up to this it is 2 and this distance is 12. So it will be 2 into 2, 2 into 2 plus half, 12 into 2. So it comes out to be 16 kilonewton meter. And A2 area is equal to, up to this it is 13. So 13 into 1 plus half, this distance is 6, 6 into 1. So this will become 16 kilonewton meter. So the maximum bending moment is equal to A1 or A2, which is equal to 16 kilonewton meter. So the right answer is A. Very good, my dear friends. Good going. So the last question for this class, my dear friend, a simply supported beam loaded as shown in the figure. The maximum bending moment in Newton meter is, this is A, this is B. Imtiaz, area of the trapezium will be difficult. You take separately UDL and UVL. So this is 14, this is 2, like this. So this is 2 distance, this is 2, and this is 12, and this is 2. So this will become 2 into 2, and this will become half 12 into 2. Right? So you take like this. Why? Because the distances are different. Area of a rectangle, area of a triangle. Sushmita Das. This is area of rectangle. This is area of triangle. Area of rectangle, you know it. If you know the area of the trapezium, directly you can take that. Ananya, IISc is the topmost institute. IISc Bangalore is preferable than IITs. Right? Okay. So now for this, what is the answer? This is RA, this is RB, and you shift the load directly on the beam. This distance is called as 400 mm, and this distance is called as 600 mm. So your RA is equal to 100 is the total load, 1000 is the total length, distance of the load from other end is 400. So the reaction at A is 40, the reaction at B is 60. So this beam can also be redrawn it as, this beam can also be redrawn it as 40, 60, and at the center you see that 100 is left over along with a clockwise movement, 100 into 100. So I am shifting this 100 at the center C. Now you see that the bending moment at C is equal to, 40 into 500, and bending moment at C is also equal to 60 into 500. So you get the answer as 20 Newton meter, one answer from left side, and 30 Newton meter, one answer from the right side. So the maximum value is equal to 30 Newton meter is the right answer. So you see that the bending moment at this point is 0. The bending moment at this point is 0. It is going up to 20. From here it is coming to 30. And there is a vertical jump because of the external movement. So this is 30 Newton meter. This is 20 Newton meter. And this diagram is called as bending moment diagram. So there is a vertical jump from 30 to 20 or 20 to 30 because of external movement, 100 into 100. Naveen, you see that whenever you talk about a beam, this is A point, this B point, this is A, this is B, this is L. So your RA is equal to total load on the beam, W, divided by total length between the support and distance of the load from other end. Distance from other end. So this is equal to W divided by length L. Distance of load from other end is WB by L is the answer for RA. So your RB is total load W, total length L, distance of W from other end is A. So the answer is WA by L. Thank you very much, Shafia. Is it clear? So my dear friend, okay, Venkatesh, thank you. So my dear friend, why should we waste time in finding out the reactions? Reaction is not giving any marks in the competitive exam, my dear friend. So reaction is one of the steps without which we cannot proceed further. So very small time should be given for that. So you can see so many classes I have taken for finding out especially the reactions for the support on our Gradeup GATE channel. So you can download the Gradeup GATE channel, Gradeup app, Gradeup Super app in your mobile, and you can see my videos. So many videos I have taken where we have seen different types of reactions, multiple forces for the support very easily. How can we find out? Is it clear, my dear friends? Okay. So definitely I will send this also on Telegram, my dear friends. So I hope that you have enjoyed the session today, understood the shear force and bending moment diagram. to get the values of the maximum shear force and the maximum bending moment in minimum time, my dear friend. Is it clear now? So please share this with your friends also. Subscribe this video. Don't forget to press the bell icon and the like button, my dear friends. So Gradeup Super is such a platform where all your dreams can come true, my dear friends. If you are interested for a central government job or MTech, MBA, MS or PSUs, definitely Gradeup Super platform is helping you in that. Gear Up and Rank Up are the two programs which are running at present. Vision 2022 is a batch for aspirants preparing for 2022 examination, my dear friends. You can see on this slide the topmost faculties who take the subject from basic, my dear friend. And this is very important slide. I want you to be here where Gradeup Super and the faculties, topmost faculties are helping you to get a very good rank in the competitive exam, my dear friend. So Gradeup Super is such a platform and a subscription model where you can get all the structured live courses and the mock test. 3 months of subscription will cost you 9,000 rupees. 12 month subscription 22,200. 18 month subscription 30,600. And 24 months of subscription will cost you 36,000 rupees, my dear friend. Right? Just a minute, I will tell you. Right? Yes, Vikas, what is your doubt? Yes, Vikas, what is your doubt? So tomorrow's topic, that is bending and torsion, my dear friend. Next class topic is sir, couple also created. Yes, couple also create a bending moment. That is the reason we are getting a difference, Vikas. That is, we are getting it. So the best book is Papau, Strength of Material by Papau, Hibler and Timoshenko and Dion. These are the good books. Yes, Kalam. So tomorrow we'll be talking about bending and torsion. Bending and torsion. So my dear friend, please take care of yourself. Stay healthy. And don't forget to be in tune with Gradeup Super, which will give an unlimited access to the structured live course and the mock test, my dear friend. Right? Please take care of yourself and your family members, my dear friend. And good night. Yes, Ibler is the best book, my dear friend. So please download the Gradeup Super app and follow me on that. Follow me on Gradeup Super app. Gradeup Super app at Rushi Joshi. Yes, Ahmad, I can do that. You can just post me your requirements on the app. I will be answering that. Right? Thank you, my dear friend, and good night.